Hey, welcome back. Hope you're all well. Good to see you again. Thanks for joining the channel. And welcome back to part 2 of this Harman Kardon HK580i. It's turning into a full-blown restoration here almost, because there's so many problems I'm finding. It just seems like it's just tripping me up every step I take. If you watch the last episode, I'll put a link up above. If you watched the last episode, I had a lot of issues and a lot of false flags, a lot of assumptions I made on my part which weren't correct, and a roundabout way we finally got the power amplifier to work. But it was working all along. It just there was other things going on that was masking it working properly. So we got our power supplies fixed up, repaired. We got our power supplies recapped. We have our power amplifier working, tuned up. We got our power amplifier tuned in, dialed in, and everything's working good there. But we still have other issues. We have something I didn't deal with last time around, is these circuit breakers. They both seem defective. I haven't decided what I'm going to do about those yet. And we have defective switches up here that are causing all kinds of nasty behaviors. So in this episode, we're going to address a lot of what's going on in the front panel here. We're going to disassemble everything. We're going to do pots and switches. We're going to do caps, and we're going to do checking everything over, make sure everything's 100%, and then we're going to move our focus onto the tuner. But let's start off with something easy. Let's work on the phono stage for now, and let's ease into this. Okay, for the phono equalization, I'm just going to remove it. That's the only way you can really work on it. There's no way you can repair it in circuit, because it's just, yeah, you got to remove it. So I'm just going to use my solder sucker here. You can use a wick if you want, or a bulb. Just going to use a solder sucker. Let me see, I might have to clean this. There, it's better. Just going to let it heat up. It's just about there. There we go, I think. I'm going to do this one. Doesn't get it all, but gets the majority of it. Then I can come back with the wick and clean it up. And that should just fall right out. Come on, get some heat to you. There you go. Okay, pull that board out. Alright, so here's the phono stage removed. It's a little module amplifier that sits in the back corner by the tuner, and it sits close to the back input jacks for the phono, so it kind of reduces lead length and hum and noise pickup, so it's a good thing. Looks pretty good. I don't see anything jumping out at me that looks awful or anything. We do have glue all over it, but this type of glue doesn't seem to be affecting the circuit at all. It's not changing color, it's not acidic, but I am still going to pick it all out, because it's basically holding down these capacitors, which really isn't that necessary on these little small caps. But we're going to pick all this stuff out, and we're going to be replacing all these caps. What have we got? 1, 2, 4, 6, 8, 9 caps. I got them all here, brand new ones. We'll replace that. So what I'm going to do is I'm going to pick out all this stuff that's in between the components, like right here. You see where it's all gooped in around the resistors. Doesn't need to be there. I'm going to remove that. Right here where it's bonding these caps together to keep them from moving, that's fine, that can stay. Doesn't really affect anything. It's just holding them mechanically. But all the other ones around these capacitors, they all have to come out because the caps are coming out. So I'll do that. This board does have some soldering issues. Let me see if we can have a peek at them. If I can zoom in good enough, maybe you could see some of these. You see the ring around these. This one here, there's a ring around it. There's a crack. This one here has a ring around it too. Let me see if I can find any more. There was a couple more. Oh yeah, there's 1, 2, 3 here. You can see those 1, 2, and 3. And the other side looks better. But we're gonna fix all that up, and we'll clean this, and it'll all look like new when we're done. So let me start scraping this. I'll remove the caps, or maybe we'll do it together. We'll remove the caps after I scrape all this, and we'll recap this. Alright, so I picked away at it. I'm just gonna, what I'll do is I'll remove all the caps, and then I can actually clean the board a lot better. And then we can clean it and put it back together. Because there's a lot of spaces where I can't get at because the caps are in the way. So what I'll do is I'll do that. But first, let's have a look at this. This is a schematic. So when you're doing recaps on audio equipment, typically what I'll do is I'll put audio grade capacitors in the audio path, and then just regular grade capacitors for power supply sections. Okay, so here's a schematic of the preamplifier equalizer section. This is this board right here, and we can see we got two 47 microfarads at the input. Okay, so those have audio signal going through them. They're going to be audio grade caps. And then we have another cap here. This is C605, 605, oh 606. It's hard to read. That's the 470. That's the big ones here. These big ones. And they are not carrying a signal. They are actually shunting to ground. So they don't need to be an audio cap. They can be just a regular cap. And then we have, okay, here's our other cap. This is a 10 at 25 volts. These are our output caps. These ones are bipolars. It's these orange ones here on the end. These are also audio grade because there's an audio path through it. And then we have this cap here and this cap here. These are on the power supply rails. These would just be regular caps. So that's the basic things of how to tell the difference between the two. Here's another cap. What they're doing here is they have a Zener diode and they have a little capacitor here that's just to clean up the noise. And this here has no audio on it. It's purely power supply, so this would be a regular grade cap here too. So that's how I differentiate between them. I just look at the schematic. If there's audio going through it, it's going to be an audio grade cap. If there's power going through it, or if it's shunting signal to ground or bypassing to ground, it just gets to be a regular cap. Alright, let's pull this apart. Typically what I do is I'll pull them out in pairs. I'll pull out all the same value capacitor on a board, and let's say if I have 5 of the same value, I'll pull them all out and then I'll replace those 5, and that keeps me from getting mixed up on which cap goes where. But this is such a small board, it's simple, and I have the schematics right here in front of me, so I don't need to worry about mixing up capacitors because I have a good idea already where they go. So let's just pull out some of these caps and get started on this. Just clamp it down, pull these out. When you're pulling caps out like this, a lot of people like to use solder wick and whatnot, you can do that way. I just do it this way. But you have to be very careful that you don't, when you're rocking the cap out, you're always pulling up on it. You don't want to be pushing down on one leg while you're pulling on the other, because you'll pop the foil trace off the board. So I can pull on this side, and then I'll pull on this side, and I pull it up that direction and pull it away from the board. Pull them both away from the board so that I don't screw that up. Let's get rid of some of this big one here. Now it's glued to another capacitor, that's why I'm having troubles here. I need to figure out where the leads are for that one. And right here, here, I think I got it. It's gonna definitely struggling to hang on, that's for sure. There we go. Let's do the other one. And these boards are marked for polarity. You have the white stripe for negative, which helps. And as you pull them out, you check the cap orientation to the stripe, make sure it's correct. That way you can trust the markings on the board or not. Sometimes they're backwards. I don't know if you've ever seen me put a cap in backwards before, but they go pop. Not all the time. Sometimes they just screw up the circuit and it doesn't work in it properly. Tip is dry. Okay. These blue Mashishita, these are the ones that leak. This one looks like it's starting to leak. So that's another reason they're coming out. Let's get this one, and then we okay, we got one more. Glues, really. Okay, I think we're clean now. We're decapped, so I'll take some time to scrape this all off. Okay, I got it cleaned up pretty good, not too bad. I could do a little better, but we'll just leave it for that for now. Let's clean up the solder joints. We got a bunch of solder joints here. Just gonna go through and open these holes up with my solder wick. Okay. Now when I initially tested the amplifier, the receiver, I went to the phono stage and it had like a rumble, a low, it was quiet, a low frequency rumble in the audio. There's no signal input, but it had that noise. And I kind of thought, well, it could be something in the power supply, which it very may well have been, because we did find problems in the power supply. One of the negative voltage rail was missing, so we fixed that. But let's see here. I got the wrong pad. Yeah, I do. Let's get this cleaned off and then we can repopulate. All right. That one, that one, that one. Where is... I'm missing one here. If you don't have solder wick, you can use a solder sucker too on this. All right. There's one capacitor here. Where is it? This little tiny purple one. I took it out from somewhere. There's a Zener. It was by the Zener. It's not marked on the board. It is C622. Do you see C622? I don't. These boards are pretty well marked. They even mark in the jumper wires. See W22 red, W24 blue, W23 blue. Even the wires are marked. But I'm missing this one capacitor. We'll find it. Okay, I got 1, 2, 3, 4, 5, 6, 7, 8. So let's just populate these back up. 16 and 15. These are the 10 microfarad at 25 volts bipolar. So we can put these in. These are bipolar, no polarity. Pull you out a little bit. Okay. Okay, these are power. Okay, we have... Oh, I need to get 2 audio grade caps. Hang on. All right, so I got... These are 47 microfarad at 16 volts. And they go here. Okay, I check polarity on all these, make sure they are correct. I'm still missing a cap though. I think it went here somewhere. Yeah. We'll figure it out in a bit. Okay, let's solder this up. That's all our caps installed. So typically what I do is I'll solder one leg. Go around and around, solder one leg on each one. I do this for a number of reasons. One is so it doesn't put too much heat on any one capacitor at one time. And the other reason is it allows you to, when you're done, you straighten them all out so they look all nice. And then they don't look all amateurish. That one's done, this one's not done. And this one's not done. Okay, that's done, that one's done. Okay. It goes from here, I know that. Somewhere here. There's two. So this is where I was soldering, so let's solder this. Let's clean some of these holes out and see where that thing went. Where is it? Oh, right here maybe. Is this it? No. I lost it. I lost it. Where does that cap go? See, 622 goes from negative 22 line to the base of 605. Positive goes to the base of 605. Where's Q605? Q605 calling. Here it is, this big one in the middle. The base is there. Okay, I see a hole here. That's where it was, I guess. I just don't remember soldering up there. Let's clean this hole out. Okay. Base 605. There's a hole there. This one had a long leg. So positive went, where's my hole again? Positive went here. Negative might have gone here. It could also be in the base of 606, which is right here. Right here, I think it is. Okay, let's do this one. It's not marked on the board. I should have looked a little carefully. There it is. There's the hole. Okay. So that would be positive. And then the negative is the other one here, I think. This one here is a jumper that goes to here. And a jumper that goes to here. Jumper. Yeah, I guess this would be the negative supply. So let's put a cap in. Positive going to the base, negative going over here. That's where it went. Okay. And I think we're good. Okay, let's solder up some of these other ones. Some of these are bad. It's possible the rumbling noise was caused by some of these cracked solders. We solder this back up, and noise goes away. We know we did our job. And these cracked solders aren't unique to just the Phono amplifier. I've seen them all over the entire receiver. So it's just something you got to look for. You have to disassemble and inspect. Okay, I think we're done. No, we're not. I got a bridge here. There we go. Okay, let's clean this up. Okay, that's better. There it is. Now, if this is really dirty, before you put your caps on, just scrub it with soap and water, and then you have to dry it with heat. Either put it out in the sun, or if you have a heat gun, something to that effect to drive the moisture out. The main thing is these capacitors, if water gets into them, they'll be destroyed. But capacitors are pretty good with a little bit of water splashed on them. They don't seem to take up too much. Transistors, they're fine. And you don't want to cause more problems than you're solving. When we're done, we'll give it a clean. Ouch. That wasn't very effective. Let's try it again. Put more on. Okay, looks like we're done. So I'll give this a good inspection and make sure we got all the cracks. Like I can see some more here on the resistors. I'll do some of these. These don't look good at all. Should have saw those earlier. You got that ring around the joint. Okay, I'll keep playing with this, get it cleaned up again, and it's done. Okay, I think the best thing to do with this right now is remove the front frame or the sub-chassis, and or the chassis piece, whatever you want to call it, and just remove it because I got a lot going on in here. I got all these function switches, they need to be addressed. And you just can't pull the board up from behind and lift it out. There is no room unless I removed the amplifier section, which I'm not doing. So I think the first thing to do is remove this dial scale here. It's not a dial scale, it's just a piece of plastic. I don't want to get this scratched up, that's why I want to remove it. And then we can properly clean it too. And let's see what this does for us. Does it come out? Oh yeah. It does want to fight us. There's a lot of LEDs holding on the back here. Okay. I'll lift this out a little bit. What's it hooked on? It's hooked on, oh, the wires are holding, that's okay. And of course there's no connectors to disconnect, so it's going to have to stay like that. Let's see here. I wish I could just remove it. I don't want it getting damaged or scratched, which it probably is already dirty. Well, I'll just do this. Remove this, and then I can put this aside. Okay, what else is going on here? The metal will leave. Just have to keep it clean. This here. Take that out. I'm sure if I look in the manual there's a procedure for this, but I think we can figure it out. It's a matter of removing screws until things fall apart, right? Okay, so our preamplifier is loose. Let's just keep taking screws out here because it's all gonna come apart anyway. This is holding screws, the switches in. one's got, that's a machine screw. Oh yeah, okay. There's a spacer in here. I have to take that spacer out. Little spacer in behind. I remember where that goes. It's like a 15mm machine screw. And there's one down here, same thing. Ooh, this one's tight. Okay, it fell out. I don't know if I'll get that back in. Might present a challenge. I want to remove the nut from the volume pot, which was loose already. Okay, let's remove these two. Basically, I'm just going to take out all the screws in the front panel, and then I can remove the ones on the sides, and this whole piece should come out. This is another machine screw. It's a mile long, and it's got a little spacer behind it. Let me see if I can dig this out. That is fighting me. I'm going to leave that in there for now. It's going to fall out eventually. Okay, let's take this one out. Same thing. We have... Can I get this one? There it goes. All right, we've got two more here with spacers. You can see this one from behind here. All right, I think we're done. Let me clean this up. These screws. One thing we need to address is this dial lamp. If I leave it there, it's going to get broken. So let's get rid of this. And what I'm going to do is just desolder it, because it's going to be flapping here and it's going to be in the way. So I'll just desolder this, pull it out. You see what I'm doing? Hope so. Okay, I'm just going to remove this here. This lamp is working and it looks like it's got lots of life left in it. It's not black like usually they are, but this it's probably been replaced. So I'm going to maybe leave this one alone. I usually do LED retrofits on these because these lamps are near impossible to find, and there's some kind of weird voltage. I think they're 8 or 6 volts or something, and I just put LEDs in here, but I'll just leave this alone, I think, and just reuse it. And that way, okay. So what we got to do now is remove the side screws. From this side as well. Okay. Everything should be loose. And it just slides. Okay, what we're going to do is we're going to feed this through the hole. Got some LEDs holding, connector holding, another LED holding, and slide this through. It's just enough room. LED holding. There, we're free. Take this out. Now we got full access to everything here. Look at this. So I can start on these switches, start on this preamplifier, and then we can get our tuner. More switches, service the pot. So we got full access now. Okay, so I'm going off to the tone board and preamplifier first. So I just removed 2 screws here and 4 nuts, and this plate's coming off. Give me full access. And separates these 2 boards for us for cleaning, and it gives me full access to all these caps, and we'll start replacing these capacitors, and then go through and do all our checks on this board. We have a little bit of glue here that is still pliable. I'm going to remove that anyways because that can go conductive. And I'll check the rest of the board out. A lot of these Mashishita caps here, and I'm looking, I don't see any corrosion on the legs yet, but they got to go anyways because they will eventually leak. Alright, let's have a look at the mystery box, see what's in here. I have a feeling it's just a bunch of digital for the tuner display. So we're just going to take a look inside, see what it needs, if anything. And check for cracked solders and all the usual stuff. I desoldered the ground, so it should come off now. Now it's holding. There we go. Wow, what's this? Look at that, somebody butchered a transistor in there. Okay. Yeah, that don't look good. A lot of caps to the case. Must be very noisy. Let's take the other side off. Have a look inside the top. There's one screw here. Okay. Come on. These things hook on pretty good. There we go. All right. Looks pretty interesting. Somebody been working on this. It's a transistor here. Transistor here. All right, I think I'll just replace 1, 2, 3, 4, 5, 6, 7 caps and be done with it. It seems to be working. I'll take a good look at those at that transistor here, see what's going on. I don't know if that's somebody's bodge or is that factory. I don't know. I'm going to clean this up first. Seems like it's got some kind of wax on it. It's got a waxy feel. So we'll clean that up and then we'll give it a little bit of work. Here's a look at some more corrosion here. You see it. I'll zoom in a bit. This battery is leaking and this resistor's got some green fuzz on it. I'm going to replace that one. And then there's a couple diodes down here too that are green fuzz. Not much on this other side. Everything looks good on this side, but down here, just want to get rid of this corrosion before it continues. So I'll have to replace this. My solution for this battery is remove it from the board and put a battery holder off on the side here on the chassis, and then you can actually take the battery out and replace it. It doesn't have to be soldered in, so I'll do that. Yeah, I'll think of something for this. Maybe on the back panel I can put something if I find something that's suitable. Okay, I just finished this yesterday. I finished recapping the tuner. Everything else here has been done. The tone board has been recapped and cleaned. Pot's been cleaned and serviced. Everything else has been checked over. Cleaned these 3 switch banks here. These weren't easy, let me tell you. But once you have it apart, it makes it, you know, it comes all accessible once you take the front off, but otherwise you'd never get that. I serviced the electronics for the digital tuning. Just put it back together after I've replaced a few caps, checked it over. And like I said, the tuner has been recapped. So now I'm at the point where I just have to start reassembling everything and put it back together, and it should be good now. Let's see, what else do I need to do? A phono stage we did. Have to reinstall that. Just a matter of spending the day and putting everything back together the way it was, and I think a lot of this was good because I didn't actually find a lot of faults with things like cracked solders and whatnot, but I did find a lot of caps that were pretty tired and pretty old and needed to go. So this is a good step, I think, especially if this is a receiver I want to hang on to. I just want to go through and recap everything, and then, you know, if it comes to a point later in time where I feel I need to sell it or want to sell it, I can turn around and say it's been fully recapped. So that in itself is a good thing. All right, So I'll get busy, and I'll see you when we get some progress happening. Just to be totally honest with you, putting this back together, I decided to try it out. I connected it up, turned it on. AM tuner didn't work, and the FM tuner sounded like it was scanning through all the channels in the band within a tenth of a second. So it was like, brrr. And I thought that was really odd. So I did some troubleshooting, and I measured the voltage of the line that goes to the variactor diodes in the tuner, and it had an oscillation on it, like it was jumping all over the place. Okay, it should be a steady DC voltage that changes with tuning, but it was just random noise. So I went over and checked over a lot of things, checked over my main board, checked over everything, and since I measured that voltage coming off that line is generated within this box here. This what do they call this box? Station Display Control PC board. So this does a couple things. It generates tuning signal for the tuner, and it produces a display for the output. Plug the display in. Okay, and it does a few other things, but when I went in here to change a cap, I made a solder bridge, and that was my goof up, and that's what caused that problem. But now it's working perfectly. Tuning works. So got that sorted. It was a little hiccup there, caused me a little bit of time. Not bad though. So everything else seems to be okay. I'm just going to finish cleaning up the front and reassembling everything, and we can get on to doing some more testing. And this will be pretty much done. Not as comprehensive as the last video on this, because I didn't have any troubleshooting to do on anything other aside from that little solder splash I left behind. But I think we're pretty much ready to wrap this up. All right, so this switch repair here, this little button repair, is giving me headaches. Now it's typically not this difficult. You drill a hole in here, drill a hole in here, use a little bit of a threaded piece of a screw, cut off the head, and use that as a means to connect the two together. But this one had been repaired previously by the owner or somebody. They had glued this on, and they used super glue, which is the wrong glue to use, and there was really nothing left in here. Usually the tip that breaks off here ends up in here, and then you can drill a hole in it and you can connect the two back together. But this case, that tip was missing, and it was stuffed with other pieces of plastic and super glue. So I had to clean all that out, and now I got nothing to glue to. You can't glue it like that. There's nothing there. So I cut out this little piece of it's thermoplastic, and I've been shaping it and thinning it down so it slides in and fits close, not perfect, but it's close. And one thing this wants to do is when I shove that in, it wants to spread the sides out, and then it doesn't fit in the here, I'll show you. So here's the front, and this button has to work without any drag, because if you get any drag on it, it's going to bind up and won't work properly. It's got to be free. So I'm just yeah, it seems okay. So let's put this aside. So what I'm going to do is I'm going to glue this in with some epoxy, and we are going to, actually I'm going to trim off probably about 1.5 millimeters, sticking out a little too far. I don't want to push it all the way in because I'll never get it out again. So yeah, I used a file and a Dremel just to thin this down. This is a piece of thermoplastic. I broke off a housing for another piece of equipment. It was in the garbage, and I trimmed it down to fit. It's going to have to go that way. But first, like I said, I want to trim off probably about 2 millimeters. And then I'm going to cement that in place. And then we'll have a base to drill our hole. So let me get started on that. Let me see here. Where is... Let me just mark this for cutting. It's not really straight. Doesn't matter. Once I shove it in there, it's going to be all good. So let's just snip off a little bit the excess. There we go. And what I'll do is I'll clean this up with a Dremel, and then I'll be right back. Okay, before I epoxy this, I just want to mask it with some tape, because guaranteed, every time I pull out the epoxy, it gets all over my hands, and then it gets over everything I'm gluing. So let's just put a little bit of masking on this, just to protect it, and I don't have to clean it off after. Okay, that should do. Come on. Okay. Now I think I have this orientated right. Yep. So what I'll do is mix up some epoxy now, and so it doesn't need much. I don't need much, just a little bit. Okay. I'm putting on way too much here. I know that. Most of it's going to come oozing out as soon as I stuff this in. Okay. That's pretty good there. I think it's flush. And it ain't coming out. Okay, I'm going to let that harden for a few minutes, and then I'll take the knife and I'll trim off the excess before it completely hardens, and then we'll drill our hole. Let's leave this here. If I stand it up, it might drain, but it won't stand. Okay, I think about 15 minutes has passed. I think this stuff's hardened up pretty good. Yep, it sure is. Let's see if we can trim some of this off. It should be still soft. Okay, looking good. Perfect. Okay. Scrape this down a little better. Now, let's get rid of this. Now, what we need to do is drill our hole. Let's try this here. Now, for the bit, I am using, let's see here. So this is my threaded rod, and it is measuring, smarten up. Just replace the battery in this thing. So this measures about 2 millimeters, M2 threads on this. And what I've done is I've gone about 0.5 millimeter less in diameter and selected this bit. This bit here is, let's see here, it's right that. So if we drill the hole too big, this won't bite. If we drill it too small, what we'll end up doing is splitting this all apart. So we got to have the right size bit. And let's just try drilling this. We only need to go a depth of about half of what this threaded rod is. So let's try this. You know, I get the hole square and straight. That looks pretty good. Got about 2 millimeters deep now. I think that's far enough. How much do we got there? Got about that much, which is half of this. That's perfect. Okay, I'll mix up another batch of epoxy, and then we'll thread this in and set it home. Okay, so we're only mixing in a small amount again. Let's just get this started. Very small amount. We don't need much. We're just gonna use this to lock the threads in place. Okay, so let's get a small amount. We'll just pack this hole with it. Let's get this started. Okay, let's see if we can, probably need a pair of pliers for this. Get this to bite and start. Here we go. Okay, let's do the same for this. Forgot to show you, I should have showed you, got a hole drilled in the end of both pieces. And they're both the same depth, which is half the length of this. They're both the same depth, which is half the length of this threaded rod. You can only put so much in and it's just going to get forced out again, so. We just thread this in. Now, we have to get this straight. Just going to give it another half a turn. Not quite there with our hole drilling. Look at how crooked that is. Pretty amateurish. But I'm just going to square it up with the piece here and let it set up. Put a little excess on here. Just to let that harden. Well, there it is, all back together, and it's set up, and it's quite strong actually. It's got a lot of strength to it. But this is a weak point, and they even know about it in the service bulletins they provide. It looks like all these models here are affected by these power switches. The HK100, 200, 300, 400 cassette decks, HK580i, HK350i, HK460i, 570i, and 680i. They all had problems with these buttons breaking. I see a lot of them broken, and I think the reason is because, here I'll show you, they're just too damn weak to begin with. If I put the button in this, when it's turned off, the button is extended quite a bit, and if it takes any side impact, and it's right on the edge here too, if it takes any side impact, it'll snap immediately, and then that's the end of it, the connection between the button and the shaft. But I think we'll do okay with this. This one's a little sticky. I might have to clean it up a bit. Anyways, there's that one. Speaking of bulletins, here's another one. This is bulletin number 1011. Change of output transistors, model HK570, 580. After serial number 15,001. Okay. 5,201. Let me see what model mine is. So mine's model 3568, so it's a low numbers unit. And this bulletin applies. Okay. What they're saying here, if you're replacing the output transistors in these two models, we recommend you perform the modifications as shown in column 2 and chart below. You replace transistors with this, from this part number to this part number, and you actually change fuses from the 3.15 amp to a 4 amp fuse. Okay, and then you change R436, 437 from 330 ohms to 470. And then here's something that's interesting. You adjust the idle current from 33 millivolts to 44 millivolts. It's quite a big jump. I think that would create a lot of extra heat. I'm finding that even at 33 millivolts, this thing, when it's running and it's sitting at idle, it's consuming about 50 watts, which is quite a bit of power. Next one here. There is a bulletin about this last station memory, and if we have a problem with this, we can fix this. It's just a matter of adding a resistor. This happens if when you switch between AM and FM, the receiver loses its station memory. You add a little resistor here to pull that line down. Okay, these are all available on what's that, Hi-Fi Engine? Yeah, that's the one I use. Bulletin number 1001. This is for the HK570, 580 output board. When replacing any defective components on the output board of the model 570 and the model 580, the following parts shall be added to the existing output board. For installation instructions, see page 2 of the bulletin. I didn't see a page 2, but they're talking about these Zener diodes, 6.2 volt, and the other diode. Let's see here. I have those already. I think they're talking about these 4 diodes here. 1, 2, 3, 4, 5, 6, 7, 8. There's 8 diodes. Yeah, 8 diodes. 4 Zeners and 4 regular diodes. And these are added between, let's see, looks like it's between the rails No, that's not the rails. This is the speaker out, and then it goes back to where the biasing is. So I'm not going to worry about that. Another bolt in here, 4006, regarding memory backup on the tuners. They're telling you, all this is just telling you there's a battery and approximate times. It'll last 3 months if it's fully charged. Different models use different methods. Not sure what this bulletin's all about. Okay, let's put the receiver back together and then we'll start doing an alignment. Let's work on the AM. We'll see how far out this is. If it really shows a big difference, we'll go through and we'll do all the steps. I got AM, FM here. I won't be able to do the multiplex section because I don't have the proper equipment, but we'll see what we can do for alignment on this. All right, I think it's time to talk about the elephant in the room here, these circuit breakers. What am I going to do with these? Now, I didn't film it, but when I first pulled these out, I tested the resistance, and one of these was open. It was like 125 mega ohms, and the other one was closed. It had, I can't remember what, 60 milliohms or something. But these are a problem. I'm looking at these. It looks like they had liquid damage. I don't know if that's just flux, because this whole thing, this whole receiver was swimming in flux when I opened it up the first time and looked at it. So I have a feeling that's just flux. That got up into the contacts or whatever. I don't know. But so I had thinking about this, and I figured, well, let's just substitute them. Let's get ones. I pulled these out of a Harman Kardon 350i. These ones are 1.6 amps, and they're no good because the ones I need to replace are 2.5 amps. All right, so okay, that's out. So I'll take that. Okay, so we have a number of options here to fix this up. We could just replace them. All right. So I did go on DigiKey, had a quick look. They have circuit breakers. Most of them are the resettable kind with a button sticking out of them. And they didn't have any of these automatic reset circuit breakers that I could see, that I searched, did a quick search. I didn't find any. So we're limited there. I could do extensive searches and find probably these exact parts. I don't know if they even make them anymore. This is what is this? This is 40-year-old technology here. Okay, so I think that's out. Now, my second option would be I could drill out these rivets, take it apart, do my contact cleaning, make sure everything's 100%, put it all back together, put some little screws with threads on them with little nuts and hold it all back together. Don't really like that idea. I don't want to open these up because not that it's going to be difficult or anything, it's just I don't know if there's a potential there for damaging it, right? Another option is I could just bypass these and just put a jumper across them and just pretend they don't exist. That would eliminate all my limited speaker protection. This is what they used back in the day to protect their speakers, 2.5 amp circuit breaker, and I don't want to do that either because if a fault ever occurs, you pop a speaker. One method I use to kind of rejuvenate these or clean them, I guess, is just run a heavy current through them and then allow the contacts to cycle. Click on and off, and with a heavy current, the contacts will, in essence, clean themselves because of the arc and the high heat that's developed when the contacts open and close. It kind of blows all the dirt and crud away from the contact surface, and you're left with fresh contact material exposed, and you get a better connection. So I did that on these, and it seemed to work a lot better. I'll show you what I did here. I'll just this power supply, and let me put you up on the power supply here. Okay, we're in constant current mode. Now let's turn this up. And we see we're at 29 volts. We don't need 29 volts. Let's turn this down to something more reasonable, like 10 volts or so. Okay. and we have our current turned down. So I'm going to short the output together, and let's turn up the current. If you don't have a self-regulating current limited power supply, you probably don't want to do this, because if you can't limit the current, then it probably just end up destroying your contacts. So let's put it up to about 2.5 amps right there on a short circuit. And I'll just open this up. Let's hook up our first circuit breaker. Okay, and let's see here. It's drawing 2.5 amps. Let's turn up the current until it trips out. Now, by now that circuit breaker should have opened. We're at 3.5 amps. Just leave it here for a while. Nope, it's not opening. It's not a very good breaker. Let's turn it up to 4 amps. Here we got 4 amps going through a 2.5 amp circuit breaker. There, it opened. Resets itself, and the cycle starts. Turn it down a bit. Okay, now I could just leave this on here and let it click away for a while, and every time the contacts open and close is a little bit of a cleaning action that's happening with those contacts. And hopefully it'll reduce the contact resistance to a point where we won't hear distortion or cutting out when we're playing music. We're at 3.7, it doesn't seem to be opening. There it goes. Okay, so what I'm going to do is I'm going to turn this right up and just let it click away for a while, and then I'll come back and we'll check the contact resistance. So these things work on a principle of bimetallic strip, and there's a little bit of a heater in there and a little bit of resistance. You got to have a voltage drop in order to get a heat buildup, and that's what they're counting on, is when you get 2.5 amps through here, there's enough heat generated on that little bit of a resistance to trip the bimetallic strip. That's what they're doing. And I can feel this is getting warm, getting warmer. And as it warms up, it clicks on for shorter periods, clicks off for longer periods. So it kind of self-regulates. Okay, so I let the first one run for a few minutes and just let the cycle through opening and closing contacts a number of times. And here I'm going to use the other one. So I'm going to connect the other one up. This one's cold. So it's just going to let it sit for a while. Oh, it opened right away. Didn't take long. I'm wondering maybe if this one's a little more defective. Let's turn that current down. Notice that when it clicks on, we're drawing 2 watts of power on about 0.5 volt. If I take the connections and short them together, that my leads are absorbing about 900 milliwatts and 1/4 volt drop across them. So let's try this. The difference between having the circuit breaker in the circuit and having it not in the circuit is about 1 watt. So that's what it takes for this circuit breaker to trip, is having, you know, more than 1 watt or about 1 watt of heat on that bimetallic strip. I'm just going to turn this one down. It seems to be a little weaker than the other one. 3.5 amps. try down to 3 amps. It might be holding at 3 amps. Yeah, it seems to be holding at 3 amps. Might click off after a while. It's going to take a little bit of time for it to warm up inside. Okay, I had both these cycling for a while. Let's test them to see what their contact resistance is now. We're looking for low contact resistance. And we're getting 61 milliohms. That's the one. Let's try the other one. 61 milliohms. So they're both identical. I think they're both good now. What I'm going to do is reinstall these and go run with them. Okay, just for comparison, here's the other two circuit breakers I pulled out of that 350i. And I have not run current through these yet. These are just been sitting in the receiver for years, unused. And I'm going to connect them up and we'll see what resistance, contact resistance. So here's the first one. And we got about 180 milliohms, which is 3 times the contact resistance of the ones I just tested. Here's the other one from the other channel. And same thing, 180 milliohms. So yeah, there's definitely oxidation at play in these things. Okay, so I just went through all the AM alignment procedures just to find out that this will not work without a bar antenna. Even though I reconfigured the input, the AM signal input, it's just not going to work. It needs that front end tuning to work. I can show you here. It's a 600 kilohertz. I'm feeding it a 600 kilohertz signal at minus 60 dBm, minus 50, minus 40, minus 30, minus 20, minus 10. It takes a really strong signal to get it to listen to anything, and it's just not going to work unless I find another bar antenna. So I'm just going to skip all that. I recorded the whole session of going through the alignment of it, but it's pretty much pointless at this point here because it did nothing for me. So let's move on to FM. All right, so we're going to get started on the FM alignments, and here we go. For alignments, we're going to need a signal generator. We have that oscilloscope, frequency counter. Distortion meter I don't have. I don't think it's necessary. AC and DC voltmeters. Let's see here. Set the function to FM position. Okay. And then set the muting switch to off. Okay. It is off. Connect the signal source to the FM terminals. Okay. These first two steps, there's no signal. We connect a DC voltmeter to test point 3 and ground. And we tune to 88.1 megahertz first and adjust LO for 3 volts on the voltmeter. And then we do the same at 107.9. And we adjust trimmer capacitor O and to about 21 volts DC. And if we look here, here's our map of where our things are. Here's LO, all right, and here's TCO. And those are these two adjustments here, LO and TCO. Test point 3 is this orange wire right here and this pin. That's test point 3. That is the tuning signal comes out of here. It's a DC signal, depending on how the tuners what frequency it wants to tune it. There's this variable voltage on that line. So let me get hooked up and we'll get this going. Okay, so we are tuned in at 88.1 on the receiver, and we are showing probably about 2.85 volts according to this voltmeter. So I'm going to go ahead and adjust TO and bring that up to 3. 3 is right here. So I'm going to crank it clockwise and up it comes. 3 volts right there. All right. Next step is tune it to 107.9. And we got a station right there. Okay, so we have to tune this to 21 volts, and we are at a little less than 21. Really difficult to see because I'm not right on. So let's turn this up to get 21 volts. Right there. We should still have our music. Okay. Next one is these two are done. Step 1 and 2. We're going to do 3 and 4. We're going to tune our generator to 90.1 megahertz. And but that won't work because I have a station right at 90.1. Let me see if there's a spot on the band where I can find an open space. Alright, so for this next alignment, for 3 and 4, we have at 90.1, which I did is I changed this to 89.1, which is 1 megahertz out, 65 dBF, and tapping off the signal on the tape monitor output jack. And we have our station setting to the correct one, yes. And we're going to adjust LA, LR1, and LR2. Now we're going to look for maximum on the voltmeter. LA, LR1, and LR2. These three are coils, and I need to spread the coil apart or squeeze the coil together to get it tuned into the maximum. I think we're going to be pretty close to where we are now. I'm just going to tweak it and see if I can get any better peaking on this. So here we are. Okay, I'm going to go for the first one. Let's try the first one. Let's see here. It's really hard to do with a camera right my way. So I'm going to squeeze this one together. Squeeze this one together. It seems to drop a little bit. Let's spread it apart a little. And it drops. Okay. You can see that slight movement on the needle. Spreading it apart. Seems to help a little bit, not much. Let me see if I can get this. Now I don't want to play around here too much because it's pretty much peaked out as it is. Let me do the second one. Oh, no. Let's try spreading it. No, it's not. It's already peaked. Actually, I think I did a little damage there. I'll just leave that one alone. I'm going to make it any worse. Third one, squeeze it together. Very minimal gain. Yeah, those are good, those three. I'm not going to touch them. Alright, step 4, we're going after 106.1 megahertz, same signal strength, but I have a station right at 105.9, which is interfering. So I'm going to change this to 106.3, and we'll change this to 106.3. And then we're going after tuning capacitor A, tuning capacitor R1, tuning capacitor R2. And we're going to try and get the same results. And here is tuning capacitor A, tuning capacitor R1, tuning capacitor R2, which is located right up here. A, R1, R2. So let me get this set up and we'll get that adjusted. Okay, going after the first one. peak was right there. You see it's peaking out. Okay, next one. If I can get it. Here we go. Okay, next one. Down. It was pretty much peaked already. Didn't get much better than that. Third one. Oops, what's going on here? Peaked out and unchanged. I'm not going to touch it anymore. Okay, step 5 repeat steps 3 and 4 for optimum sensitivity. I don't think I'm going to get any more out of that. Tweaking that. Step 6, no signal. Frequency counter to test point 4 and ground. We're going to set the station display to 98.3, and we're going to adjust TC801 for 109 megahertz on the counter. Test point 4 is right here beside test point 3. Test point 4 is this white wire here that goes into this black coax, and this black coax goes into the box. This is adjustment TC801. Okay, so our station is set to 98.3. There's our frequency counter. It's pretty much bang on. Let's adjust this. We're looking for more accuracy on this number. I don't think we're going to get too close. It's pretty... I'll turn it clockwise here a bit. It looks like it's going down. Keep going. Oh, there we go. Go back up a bit. Right there, I think. I remove my hand and it jumps. When I put my hand here, that's not bad. Well, it's jumping around still. I don't think we need to get it exact. Let's try this. That's pretty good. I'm going to leave it at that. Alright, this next one here is kind of confusing. It doesn't make sense to me. They're telling me, first, step 7, set the muting switch to on position. When I turn the muting on, I lose my signal because it's not that strong. Set the signal generator to 98.15 megahertz. Scope out the jack, the tape one. Set the station display to 98.1, which I have. See, they're asking me to detune this for some reason. And then adjust T201A for a clean wave on the oscilloscope. T201A is right here, and that's part of the discriminator coil. Now, let me see if we can do this. I have to turn the muting off, and then I'll show you what my signal looks like on the scope. Now, it looks like this because we're detuned. If I tune back to the station center frequency, which is there, we get a perfectly clean signal. But if I detune it by 50 kilohertz, that's what we get. So let me try adjusting this. We'll see how close we can get this or what's going on. We're going for max or minimum distortion. That's what we're going for. So let me... Oh, that one's tight. Okay, let me go this way. Nope, not that way. Nope, not that way. We'll just go for maximum amplitude. we're not going to get rid of that distortion because we're detuned. That's why I don't understand. Okay, so let's do this a little different. Let's set this up so we have the correct frequency here. There we go. And let's tune T201A to get maximum signal. Not there. Not there. Right about here. That's peaking it right there. Okay. Oh, I see what they're doing here. Okay. So I detuned it to 98.15, get maximum. Now I detune it to 98.05 and I get maximum on the same adjustment. Why would I do that twice? Let me try it. Here is 98.05. You can see it's starting to distort on the top of the waveform. Here is 98.1 clean signal. Here's 98.15 heavy distortion on the bottom. So we want a happy medium between all of those, and I think tuning this isn't going to change anything. There's my distortion free, a little bit better. Cranking this the other way and it just kind of blah. Okay, let's go back here. And we'll set this to maximum signal, least distortion. Okay, let's go down to 98.05. Let's try this again. To the right, nope. To the left, and it peaks out right about there. You know what? I'm just going to set it for peak at the center frequency, 98.1. We're going for maximum signal here. And I think it's right there. That's pretty close. Yeah, not bad, not bad. Okay, step 10 is repeat steps 8 and 9 for optimum sensitivity. So I'd have to do these again and again, but I think we're there. Step 11, 98.1 megahertz, distortion meter on the output. I don't have a distortion meter. 98.1, and we're going to adjust T201B for minimum distortion on the distortion meter. Just wondering if we can do this another way without a distortion meter. We can do this another way without a distortion meter, that'd be great. So let's check B. Let's try turning it. Wow. I don't know if this is getting us any closer. Looks like we're getting distortion on the bottom now. If I crank it clockwise, it drops. Let's go back up here. Let's peek this out. Right here. Okay. Let's peek out. I'm going to leave that alone. I think that's it. It says repeat steps 8, 9, and 11 for optimum alignment of T201A and B. And I think we're there. Let's go on to the next stage. Quartz locked indicator. So what we're doing is we're going to just, we're setting up a signal 98.1 megahertz, 13 dBF, 2.4 microvolts. Let me turn my signal generator down to microvolts. 2.4 microvolts, that's pretty much nothing. Alright, so it's asking for a small signal here. 2.4 microvolts. It's telling me to turn VR351 to the center. VR351 is right here. And then adjust VR201, which is right beside it, right here. So let's turn this to the center. It's way off to one side. Okay. And then I adjust VR201 until the quartz lock light comes on. And it doesn't. Isn't that nice? Okay, so I adjusted our VR201. I can't get it down to 2.4. I can get it down to about 4 microvolts, and we've got this all set up properly. So that's where I'm going to leave it. Let's move on. Next step is to set the signal strength display adjustment. We're going to skip the AM adjustment for now, and we're just going to focus on the FM. So we're going to place the generator leads across the FM terminals. We do a 970 microvolt signal. DC voltmeter to test point 5 and ground. 98.1 megahertz on the station setting. We're going to adjust VR351 for 9 volts on the DC voltmeter. Test point 5 is right here. And it is a jumper wire. This jumper here I believe is test point 5. It's not marked on the board. I wish it would. I wish it was. We'll connect up there and we'll measure 9 volts. Alright, I'm going to adjust VR351 for 9 volts, and I got a little bit high here, so I'm going to turn this down a bit. Actually, there we go. There's 9 volts. And we got 5 bars on the meter. Next is the MPX adjustment. FM signal generator modulated with 1000 Hz tone at 100%. You need a frequency counter. Set function selector to auto FM. Okay, so stereo FM. Connect the signal source to the FM terminals. We're going to feed in 98.1 megahertz at 970 microvolts, which is what I got right now. Frequency counter to test point 6 and ground. This test point 6 is right here on R307. It's a 10K resistor. Okay, so let's see if we can find 306, 307. 307, where are you? 306, I see 306. Oh, right here. Okay. 307. Right there. And we adjust VR302 to get 76 kilohertz on the counter. I'm pretty close there now. Let me show you. And we need to adjust 302. Okay, where is 302? I'm trying to find it here. 301. If I look on my map, maybe it'll tell me. 302 is right beside the connection. Okay, let's turn this up to 76 kilohertz. And go the other way. Wow, it's really going out. Let's try it clockwise again. Okay, there we go, we shot it. Back it off. We're getting close. Too far. Wow, it's very touchy. Too far. And down a bit. I'm going to give this little trim pot a little deoxit just to get it cleaned up because it's not working that great. Just a little dab. And let's work it in. Maybe we can get it better. Okay. 76.8, let's turn down. Ooh. Getting better. Yeah. I'm going to leave it there. That's good. We're close enough. Alright, so that concludes the adjustments I can do. After this, it's stereo adjustments, and I do not have a stereo generator. So I'm going to skip this one, and I'm going to skip these 5. And that's it. Aside from that, we have idling current and DC offset, which you already adjusted, so everything's tuned on in the receiver. So, shut the signal generator off. Let's have a listen. Alright, so let's have a little scan through the band. It's picking up stereo, no problem. No antenna on this, so getting a weak signal. We're not getting, oh, there's the stereo. It takes a little while for the stereo to kick in. But it's working good.
Swim code now. Edmonton.
Yeah, it takes a second or two for the stereo to kick in. On the weaker ones it takes a little longer. Come on, you can do it. Doesn't want to. Yeah, it's getting very weak signals. I do not have a proper antenna here, so let's see if that makes any difference. Okay, I think I'm gonna wrap this one up because I think it's done. I don't have anything. Oh, one thing I want to talk about is the NiCad battery. Here's a look at the NiCad. It's got corrosion coming out both ends. It's dead as a doornail. I removed it. I'm not going to replace it because at this point I'm not going to use this tuner. And if I do ever come to a point where I want to use this as a daily driver, probably what I'll do is I'll put a little battery holder in, and then I can just snap in a new NiCad. I can charge the NiCad up, snap it in place into the holder, and then it'll work. And if I do decide to take it out of service, I can always pull that battery out. And I'm thinking maybe I could do it somewhere on this back panel. I'll see if they have AA or AAA battery holders that are panel mount, and I can like access the battery from behind, opening a little door or taking a cover off, and then I can add the battery. It's easy to do at a later date. You don't have to do it today. So I'm going to leave this part out. Here is the rest of the mess. These are all caps that have been changed. I got some other parts in here too that have been changed, some diodes, a few resistors that have been attacked by corrosion, and those dead fuses. Everything else has been replaced. Alright, thanks for watching. We'll see you on the next one. Thanks for watching, and take care.